Assalamu alaikum. Bismillahirrahmanirrahim. Today, question number 18 of chapter 11, Thermochemistry, is under discussion. And this question is that is the conversion of magnetite, that is Fe3O4, to hematite, that is Fe2O3, by oxygen endothermic or exothermic? You are to tell that whether it is exothermic or endothermic conversion of magnetite to hematite. Dear students, as I have told you time and again, that first of all, in such questions, you are to write the target or required or desired equation. When you write it at the very first step, then it becomes easier for you to manipulate the different equations which are given in the data. So we are to write first the required or desired equation, and desired equation is written at the top, that is Fe3O4 plus O2 gives us Fe2O3. So you are to learn by heart the different formulas, at least these two oxides of iron, which are magnetite and hematite. And after writing this equation, you are to write in front of that, which is not written here, delta H naught equal to next question mark. So number one is to write the equation that is required, to which equation we are to reach. After that, write the equation for the formation of magnetite, that is given as equation 1, which you are watching on the screen. Iron plus O2, and the product is Fe3O4, that is the formula of the magnetite. Or balancing, put 3 with iron, O2 with 2, and the result Fe3O4. And along with this, you are to write the enthalpy, that is enthalpy of formation. So you are to write enthalpy of formation value, which is given in the data, or even in the question, or in the book. Second is to write equation for the formation of hematite, that is second ore of iron. So equation under heading equation 2, you can watch that there is iron Fe solid state plus O2, after arrow Fe2O3 is written, and in front of this equation enthalpy of formation of hematite value has been written or given. So these are equations 1 and 2. Balance it, 2 iron, 3 by 2 O2, that would be equal to 3O, and in the product side you will have Fe 2O3 only. After that, you are to multiply equation 1 by 2 and equation 2 by 3. Multiply equation 1 by 2 and equation 2 by 3. After multiplication, equation 1 would be in the form which is written as equation 3, 6 Fe plus 6 plus 4O2 given us 2 Fe3O4. And you are also to multiply enthalpy's values too with the same number. In next equation, that is equation 4. After multiplication you will have also 6 iron plus 9 by 2O2, and in the products you will have 3Fe2O3. And also you have to multiply the enthalpies values with the same number. Now reverse equation in such a way you have to subtract that equation in which the thing you are required is should be in the opposite side. So reverse the equation 3 and then add it in equation 4. So while you are reversing, it means that things that which are written on the product side now should be written on the reactant sides, and reactant sides will become the product side. Otherwise, I have previously told you that you may put negative signs, you may subtract it. But if you write after reversing the equation, then you have to add both these equations. So after reversing equation 3 and adding it in equation 4, you will get the final equation. You find that irons will be cancelled out, and finally you would get 2Fe3O4. 4 plus half O2 giving us 3Fe2O3, and you are also to put the same way their enthalpy values, different enthalpy values. If addition is carried out, then you are to add. If multiplication is carried out, you are to multiply. If subtraction is carried out, you are to subtract these values one from other. In this way you can get your final answer. That is a simple way, a simple question, but I think that there may be in the textbook coefficients will not be in a may not be in balanced way. In different editions of book you will have different coefficients. So in this question they are, I think that properly they have been properly put. So by main process is the same. By the way you have solved your two previous problems, same is the here. Write the target or required equation, then write equations for the data that has been provided, and then addition or subtraction or reversing of the equation is carried out according to the demand of the question. And I have previously told, once again I am emphasizing that values should be, the enthalpy different values should be treated in the same way as is treated the balanced chemical equation. That is, if you are to multiply the reactants products with some number, you are to multiply their enthalpy values also. Only then you can get the proper answer. So in this case, since negative sign is given, is magnetite to hematite is an exothermic process. In such process heat is evolved, so you can only deduce after performing these calculations. Then you can decide that whether the reaction is exothermic or endothermic, and also you can put this question in another way. You can solve this question in another way with the help of their enthalpy of formation values, but I think that according to Hess's law, that is more proper to solve questions in this manner. So I hope that this video will be also helpful to you, like your previous problems. You after watching this, you are to write these equations on your paper and only then you will be able to solve these questions in the exams. So continue and with yourself hard work that is actually brings laurels for you. Okay, thank you. Allah Hafiz. Pakistan Zindabad.